All right, this is day 49. Let's get it. So today is a hard question. You are given a positive integer n representing the number of nodes in an undirected graph. The nodes are labeled from 1 to n. You are also given a 2D integer array edges, where edges of I is ai bi indicates that there is a bidirectional edge between nodes ai and bi. Notice that the given graph may be disconnected. Divide the nodes of the graph into m groups, one indexed, such that each node in the graph belongs to exactly one group. For every pair of nodes in the graph that are connected by an edge ai bi, if ai belongs to the group with index x and bi belongs to the group with index y, then y minus x should be 1. Return the maximum number of groups into which you can divide the nodes. Okay. Return the maximum number of groups into which you can divide the nodes. Return -1 if it is impossible to group the nodes with the given conditions. This seems like a very different question. So seems like a level order traversal kind of a deal, but we do not know the root, or if we start at anything, like let's say if I start at 4, then adjacent to 4 are 1 and 6, so they'll be in the separate groups, right? So if they're connected to each other, they cannot be in the same group. Correct? Yeah, makes sense. So if there are 3 neighbors, no. I mean, it is possible, but still. Now 6 could be either in group 2 also, right? And that would work. Okay, makes sense. Okay, this seems have I done this? No, I haven't. Okay. So first of all, we build a graph, adjacency list, right? Then we start BFS from any node, right? Edges can be 10,000 and edges. Okay, makes sense. Okay. Yeah, I mean, yeah. So let's make a graph, and are the nodes 1 indexed, labeled from 1 to n 6. Okay, let's create adjacency list from these edges: 1 2 3 4 5 and 6, right? 1 is connected to 2 and 4. 2 is also connected to 1 and 4 is also connected to 1. 1 is connected to 5. That's all. Then 2 is connected to 6. 2 is connected to 3. 3 is connected to 2. 4 is connected to 6. So this is the adjacency list from these edges. Now if we start from 1, let's say. Now for creating the groups, I'll use a hash map. So hash map from integer to a set of integers. This will be the group, basically group that will contain the nodes, right? This is the set, and this represent the neighbor index, basically index it. So I can start from 0 and I can go negative because this will support that, so that's fine. So let's start with 1, and I will do a BFS on here. Now I have two options here, right? I can either put 2 to the left or to the right. Let's say let's draw this. So I chose 1, right? So let's say this is my data structure, or okay, this is group, right? 0, 1, 2, 3, -1, -2, right? Let's say I choose 1 to be put in group 0. I put 1 here. Now neighbors of 1 are 2, 4 and 5, right? So I can either put 2 here or here, correct? Where should I put this 2? Now here is a, I mean, what do you call DFS or whatever, recursive solution, but that would make the time complexity as well as space complexity, it will go through the roof. It will blow up the chart. So that's not let's not do that. Okay, can I choose a group for 2? No, I can't, right? What if I put it in both? Nah, that's not gonna happen, right? Six could be here, yeah. Let's put 2 here, right? And we have 4. I can put 4 here or here. Why does he put 4 here? I can put 4 here as well, right? And let's put 5 here. Now I have 2, right? So I'll go to 2. I have 1, which is visited. 6. I can put 6 here, right? Let's put that. Let's put 6 here. And let's put 3 here. Right. Now we go to 4. For 4, we have 1 and 6. 1 is here already, and we need 6. 6 can't be here. So 6 has to be here, right? Okay. Bro, this is a tricky one, and I am making this too complex. I can already see this, but there is one relationship here. If a node is connected to two other nodes, Then formation could be in two ways mainly. It could be like this, or it could be like this, right? Two of these nodes can be in one group and this in another, or they can be in three separate groups, right? These are the two formation. There is no other thing that is possible here. Which one should I choose? Let's see, what are the topics here? Pre-FS, union, find. Okay. Let's look at the solution, man. Bipartite check. What the fuck? Let's take a look at the why bipartiteness. What is bipartite? Is that the color thing algorithm, like color the graph with the two colors, and no two neighboring nodes should have the same color? I think that is what bipartite was. But we can check with our here in DSA. We go to graphs, graph. Do we have a bipartite here? Segment tree. I have never read this. What is bipartite? Bipartite graph. A bipartite is one whose vertices can be split into two independent groups, U, V, such that every edge connects between U and V. SCCs can be thought of as self-contained cycles within a directed graph where every vertex in a given cycle can reach every other vertex in the same cycle. Okay, let's understand. We are given a graph with n nodes represented by a 2D array edges, where edges of I, U, V means there is a bidirectional edge between nodes U and V. Our task is to divide the nodes into the largest number of numbered groups. Largest number of numbered groups such that each node belongs to exactly one group. If there is an edge and U is in group X, then V must either be in group X minus 1 or X plus 1. Correct. Sometimes this kind of split is not possible. For example, consider this graph, right? Okay. Invalid split, nodes 2 and 3 are directly connected and they are in the same group, so that's not possible. Now if we have in here nodes 1 and 3 are directly connected, but okay, correct. Yep. Oh, what? Do we just have to find? No, I don't get it. Here no valid split exists. In such cases we return -1. A key observation is that if it is possible to divide the nodes into X groups where X is greater than 2, we can also divide them into X minus 1 groups. What? If it is possible to divide the nodes into X groups, we can also divide them into X minus 1 groups. Intuitively this works because the nodes in the first and third groups can't be directly connected, but they must all connect to the nodes in the second group. By combining groups 1 and 3, we get a valid split with X minus 1 groups. That is also, yeah, that is a valid observation. Correct. I mean, I can put 1 in this group and it will still work. So to check if a valid split is possible, we just need to see if the graph can be split into two groups. In other words, whether it is bipartite. A graph is bipartite when we can divide its nodes into two distinct sets, where all edges connect vertices from one set to vertices in the other set. No edges exist between vertices within the same set. Okay, another key detail to consider is that the given graph is not always connected. In this case, we calculate the largest number of groups. For each connected part of the graph and then take the sum of these numbers. To sum up, the problem boils down to these steps. Check if the graph is bipartite to see if a valid split exists. For each connected part of the graph, find the largest number of groups so you can divide the nodes into and return their sum. Okay. To solve the first part of the problem, note that once we assign a single node to one of the two groups, the rest of the assignments are automatically determined. Nodes directly connected to the first node must go into the second group, their neighbors, and so on. Yep, that is easy. To check if the graph is bipartite, we color the nodes using two colors, ensuring that any two connected nodes have different colors. If this coloring fails, the graph is not bipartite and we can immediately return -1. If the graph is bipartite, we calculate the maximum number of groups. We can divide the nodes into 4, each connected component separately. Intuitively, to achieve the largest number of groups, we spread the nodes as far apart as possible. This means that instead of simply assigning a neighboring node to the same group as the one it was previously associated with, we always try to assign it to a new group. An important observation here is that the maximum number of groups in a component is determined by the longest shortest path. What? The maximum number of groups in a component is determined by the longest shortest path. What the fuck does that mean? Between any pair of nodes in that component. Longest shortest. Okay, this is similar to finding the height of the component if it is structured like a tree. Yeah, that is fair. Correct. Finally, we repeat this for all connected components in the graph and sum up the results. Okay. So we find the farthest nodes from any node and then find farthest node from that node and get the height basically, and height is equals to the number of groups. Makes sense. Okay. Okay. Yeah, fair. Okay. Yeah, I understood the solution now. But it's now time to write, and I don't know I mean, okay, let's write. So first of all, we need an adjacency list. So it will be int adjacency list equals new int n. Okay, let me see how I did adjacency list in one of the previous questions. Okay, redundant connection, I don't know, maximum number of fish, course schedule 3. Fuck. So this was union find. Is there an adjacency list here? Nope. Adjacency list here? Nope. Okay, brother. Can I see what I solved using Java? Oh man. Adjacency list in Java. Okay, let's look at this, guys, what he wrote for adjacency list. Array list, new array list of size n. Okay. Hi, Yash Wandre. Please solve this. Please solve this question 50. Power of x of n. Okay, it's recursive, I think, right? Recursive thing, and explain me the solution also. Let me do this question first, and then we can jump on that one. How about that? So this question is pretty epic. If you want to see, it is 2493. It is related to graphs. It's very good. Okay, now here we have our graph adjacency list. Now we want to check if it is bipartite. Now actually this graph can be disconnected, right? So we need to check for every node if. Also, let's create a visited thing, boolean visited of n. If it is not visited, and is not bipartite, I graph and visited, then return -1. I can take this condition inside, right? Then return -1, else it means that it is bipartite, so we need to get the longest shortest path. So res equals 0, res plus equals get longest shortest path length. Here we'll pass I and graph, correct? At the end return res. Now let's write these functions, which is the big part of this problem. boolean is bipartite. Int I list of integer graph and boolean visited. If now here is bipartite. Let's understand the logic. Let's say we have any graph. I start with this. I color this as red. Now when I pass it to neighbors, it should be green. Right? So I can switch between colors and do a DFS kind of a thing. Right? And I don't need to go back again. So let's start with color 0. Right? Boolean color. If it is visited I, then return true. Correct? Else visited of I equals true, and then we need to store color as well. So damn. Okay. Boolean color equals new boolean n, and let's pass this also, and this will be current color boolean colors. Okay, so I visit this, and then colors of I equals current color. Correct? If colors of, okay, let's make it int. So basically 0 means not colored, 1 is red, and 2 is green. We can do this way. So if colors of I is equals current color, then return false. Visited of I is true. If colors of I is not 0 and colors of I is current color, is not current color, then return false. Else we paint it, we visit it, we paint it, and then we return. Okay, we do a BFS here, or we basically see the neighbors, right? Integer neighbor in graph dot get I. Correct? if not is. BFS could have been way easier. Well, let's see. Is bipartite neighbor graph visited. Now current color will be switched. Current color equals 1 question mark, then 2 else 1, and then colors. And return false, else return true. I can test this first. Boolean and int. What? Oh. What? Dot add. Okay. You know what? Let's do BFS here. So int current color equals 1, int colors equals new int graph dot size. Okay. New linked list, q dot add I, while q dot empty is empty. Int size equals q dot size, while size minus minus is greater than 0. Then int node equals q dot poll. Correct. Colors of node equals current color. Visited of node equals true. Correct. Then for every neighbor, integer neighbor in graph dot get node if not visited neighbor q dot add neighbor. And at the end of each layer we switch current color. Correct. And here if colors of neighbor is equals to current color, then return -1, right? Return -1 or false. Okay. We don't need this shit. Okay. So is bipartite is working now. Now we need to write a function to get the longest shortest path length from I graph. Do we need visited? Nah. So I'll take the function definition of this guy. Int, and then we copy this function name from here. Now this is a tricky one. I just need to do BFS twice, right? So let's take a q integer q equals. Now q dot add I. Let's also take visited, correct, while not q dot is empty. Size equals q dot size. Now here we need while size minus minus is 0, then int node equals q dot pole. I can assign it to farthest node, and then for integer neighbor in graph dot get node if not visited neighbor q dot add neighbor, correct. Okay, and at the end I'll get the farthest node from there, right? Now do BFS again. Q dot add farthest node. Now just do a level order traversal, right? Set all values of a boolean array to false in Java. Okay. Arrays dot fill visited false, right? While not q dot is empty, int size equals q dot size. Same shit. Int node equals q dot poll. For integer neighbor in graph.get node, if not visited, at the end group count plus plus, return group count. Okay, let's see if this works, man. Okay, wrong answer, 5126. Now here I believe, okay, something is wrong here. Expected 4 output is 3. There is a possibility that there is some disconnected graph here. But what have I done wrong? Okay, I can check. If group count is 0, then return 1, else group count, right? Yeah, this is possibly this case. No. What happened here? If group count is 0, while size is this, there are no neighbors, right? Yeah, it makes sense. For visited, if it is not visited, we don't need this. If it is not is bipartite, then return -1, else longest shortest path length I graph. Okay. Oh, just 0. Okay. Let's see the solution. Okay. Colors, new int n, arrays dot fill colors -1. For each node, if colors node is not -1, if colors of node is not -1, continue start. Colors of node is 0. Okay. Okay, this guy has taken colors as global. Okay. Okay. Calculate the longest shortest path for each node. Okay, in distance he performs BFS layer by layer. Correct. Oh. Okay. Then what does this function? Get number of groups for component. Start with the distance of the current node as the maximum. In max number of groups is this. We just reduce this recursively calibrated. But okay. What was that question? Height of a graph. Leetcode. Okay, I don't get this point. Oh, come on. Summing up max depths. Max of magnet max depth. I mean, get max depth and start an ordered set component nodes. Okay. 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 Then for every node, we are calculating the distance of. Okay. What the fuck is this? BFS max depth. I mean, I don't get it, bro. Yeah, maximum width of binary tree. Yeah, I did this question, no? Shit. Bro, I mean, I don't know what the how do I see? Okay. Top K, find minimum length of strings, word subsets. Yeah, minimum diameter after merging two trees. Okay, q dot add visited source true, int farthest node equals source. Damn, that was scary. While q is not empty, then for current dot poll farthest node equals current. integer neighbor int size equals, okay, max distance, okay, for int I is 0, I is less than size, I plus plus. Okay, if q is non-empty, then max distance plus plus. Wouldn't using C++ be more try-hard? I mean, it would be way easier with C++ because Java is the most shit language I've ever seen. Okay. Why does this throw 3, man? What the fuck? If it is not visited. Okay. So this solution says get the depth. I mean, I don't get this point. Get longest shortest path function. Initialize a queue and a visited array of size n. Push source node into the queue and mark it as visited. Initialize distance to 0. While the nodes queue is not empty, initialize number of nodes in the layer to the size. Process all nodes, correct? Basically doing a BFS, and then for each neighbor, if it is not visited, then push it to the queue, increment distance by 1, return distance. Wait a second, okay? Okay, then what? So here what we are doing, man. Let's draw this graph. So we have 1 connected to 2. What else it is connected to? 2, 4 and 5. 2, 4, 5. What else? 2 is connected to 1, 6, 3, 1, 6, 3. 3 is connected to 2, 4 is connected to 1 and 6, 1 and 6. 5 is connected to 1, 6 is connected to 2 and 4, correct? Now, what does this say? Push source node and get the distance. Okay, let's see the function. Okay. We have a source node, we know the number of nodes. We do a visited thing, then visited of source node is true. Okay, then we do BFS layer by layer, correct? Number of nodes in layer, correct? Current nodes, correct? Then for each neighbor, if it is not visited, then add it to increment the distance, return distance. Longest, shortest path. Okay. I mean, just like how many layers from that node are there in the graph? Is that the thing? Then what does this function do? Get number of groups for component. We assume that this is the max number of groups. Then we go to each neighbor and in a DFS way we maximize for that connected component. I mean, okay. Why don't we calculate the diameter of that graph? What is the difference? And why does this matter, man? What the fuck? You know what? Let's write this way. Okay. So get longest shortest path length. Okay. So visited, we have queue, bang bang bang. Queue is not empty while size is this. We don't need this. For each neighbor, push it to the queue, and we just need a distance. After every layer, we increase the distance by 1 and then we return distance. We don't need any of this bullshit. And then we write another function, get max groups possible from source, and then we have the graph. That's all right. Now int max groups. Okay, we also need that distance thing, right? Which will be here, distance of source, and then return, or sorry, for each neighbor in that source, max groups equals math.max of max groups, or the distance, max groups for that neighbor, right? And at the end, return max groups. Okay, brother. Now let's take a distance array here. And what the fuck have I done here? N. This is also N, by the way. Now distance of I equals this, and result plus equals get max groups possible from this source with this graph. Get max groups possible, line 55, 56. What happened here? Math.max. What? What's wrong? Ah, my bad. Okay, is cannot be applied to given types. Get max groups possible. I. The fuck does that mean? Method get in class solution cannot be applied to given type. Oh, what? Distance. Dist. Okay, in this we messed up. Graph.get source. Now we need to keep track of visited as well. Fuck. Damn, bro. Fuck this question. Boolean visited of source equals true if it is visited, then continue, and in the function call we can pass a new boolean of size n. Oh shit. Visited. I'm about to lose my mind. fuck this question. I'ma fuck this question. Now what's wrong, man? Oh fuck. I need to do this in a separate loop. This will still be wrong because we need a visited thing again. Right? If okay, has he passed this visited as a common thing here? Okay. Oh man. Bro. Okay. Okay, we created an adjacency list. Then we did a colors. If is not -1, then continue. And color that is by bar edit on -1. Okay. Calculate the longest shortest path for each node. Distances visited, max number of plus equals, and then get number of groups for component. Oh shit. Fuck, man. Fuck. For each node we need distance, man. Fuck this. Okay. Okay. Please, man, please. Okay, it works finally. It's been an hour. What the fuck, man? So today we learned about what is bipartite graph and how to like what how to do this question basically. The fuck, man? Who asks these questions? Bro. Anyways, it was good, man. It's all right. Okay, so I will be back tomorrow with another set of questions. Today was a good day. A hard question. So, yeah. Okay, let's do that power question also. Why not, right? Leetcode power question. Yeah. This I know. I mean, implement power of x to the power of n, which calculates x raised to the power of n. Okay. Now, here is one trick for this question. Now, we simply just can't do like multiply. Now x can be negative as well. Yep. Okay, let's draw some shit. Okay. Now, what is x to the power of n? X to the power of n is equals x times x to the power of n minus 1, correct? Or, now if n is even, I can simply do x to the power of n by 2 multiplied by x to the power of n by 2. And right, if n is odd, then it would be x times this thing, right? X times n minus 1 by 2 basically, right? X times x n minus 1 by 2 times x n minus 1 by 2. Now, there is one more criteria of negative. Now, we can simply, we know that negative times negative is positive. So if n is even, the overall answer would be positive in both cases. But if n is odd, when x is odd, it will be negative. So that is the solution there. Let's try to write this now. If n mod 2 is 1, then return my power of x n minus 1 by 2, right? Multiplied by times x, right? Or I can simply just make this way easier for okay, so if n is even, yes brother, yes, I'm doing the question now. Power of x to the power of n. Okay, if n is even, then do that, else return x times my pow x n minus 1, right? Now here, if n is 1, then return x, correct? Right? If n is even, then do that. If n is odd, do I need to handle minus 1 in this case? I don't know, man. Maybe. Okay, Stack Overflow. We fucked up. What happened here? N by 2, n by 2. If n becomes 1, then return x. When n is even. N by 2, okay. When n is 1, return x. Okay, 2 by 2 is 1, 1, okay. Okay, when this is 3, let's say, it becomes 2, right? If n is 0, return 1 base case. Okay, let's also write that. If n is 0, then return 1. Right. If n is even, then we split it. Okay, something's wrong here. My power of x. Okay, yeah, I get your solution, but that would be, I mean, that can exceed time limit. Come on, bro, you just have 15 minutes to solve it in interview. Yeah, that is correct. Yep. That's why I'm preparing, brother. But the solution that you gave in chat would be, I mean, would exceed time limit in my opinion, because we are going one by one. We are not splitting n, right? Okay, n is negative 2. Oh, n can be negative. Okay, n can be negative. No one told me that. So if n is negative, then okay. Yeah, it is 1. Okay, we divide the whole result by 1. So let's take double DFS, or whatever, let's call it. DFS is probably fine. Double x int n. We copy all of this shit in this function. Then we can simply do, if n is negative, then return 1 divided by DFS of xn, else return DFS xn. Still, absolute of n. I think this is math.abs. Okay, let's see if this works. Okay, time limit exceeded 294 test cases passed. When x is this and n is a very huge number, it is exceeding time limit. Okay. Do we need to cache something? Do I need a cache? What can I cache? I can cache like the result of some numbers, right? Okay. For last return, why we are not putting else? Because we are returning the value itself, so we don't need it. The control will never go to this line. I mean, if this is not true, then this will definitely execute. Also, if we do not put return at the end, Java throws a warning. Okay. Now for this, let's use this test case first. Should I cache values here? I mean, yeah. While absolute of n is greater than 0, if absolute of n is 1, return result equals result times x. Yeah, that we are already handling, I believe. Okay, but now for this, let's add a cache, brother. Does the question say not to add cache? Either x is not 0 or n is greater than 0. And x to the power of n will be in between these two values. Okay. I mean, so, but yeah, what to cache here? It's a double. Now, since x is constant, x is same, right? So I can simply take n. Now n can be negative, so that's a problem. But yeah, n will be positive in our case because we made it positive. Okay, so creating a cache of this would be crazy. Try my solution. Let's try. Copy, Control C. Let me comment this solution. If n is 0, then return 1, else return x times. Okay, this I believe will be time limit exceeded. Let's check. Okay, this is first of all, what's wrong here? Return 1x times my power of x and my... Yeah, we are not handling negative n values here. So okay, have I done this previously? I have. Okay, I've done this and I still can't do it again, man. What the fuck? Caching is not a solution. Okay, a very small value and a... okay. You know what? Let's fuck it. Let's add what do you call it? Cache equals new double, or let's do a map from double to double. No, integer to okay. Cache equals new hash map. I don't think this will work, but whatever, man. Cache dot put n and the value of this, right? If cache dot contains n, then return cache dot get n. Contains hash map java get remove contains key. Because the return value of this is null. What? Cannot invoke double value because the return value of this is null. Ah. Okay, cache works, but let's see if it is accepted. Okay, 3 test cases. Number format infinite or NaN. Number infinite or NaN. What? So this cache exploded probably. Okay, let's look at our previous solution. Okay, pretty small. If n is 1, then return x. If n is odd, then x times this, else return this. Bro, I did the same thing. If n is less than 0, then return this, else return this. Bro, we want to return integer. Congrats, proud of you. We want to return integer. What? We don't want to return integer, brother. But this solution doesn't work, man. Like, oh, okay. If n is 1, then return x times this, right? Else return this. Okay, wait a second. If n is odd, then return x times n by 2, n by 2. Okay, so this was the problem. Damn. We can't do n minus 1 at any cost, because n minus 1 will slow us down. And when n is odd, and n by 2 and n minus 1 by 2 gives the same result. So this was the trick. So there is no, minus 1 is not allowed at all. Okay, still time limit exceeded because now what happened? If n is 1, return x. If this is this, then return this, right? Else return that. Okay, in Java it's not working. Let's try this solution in C++. Maybe the test cases are updated now. Okay, C++ gives accurate result with the same code, but Java is slow. So how do people write code in Java? It's the same shit, man. That's why C++ is the GOAT, man. So is there any solution with Java? Give me a Java solution. What is this? What is this guy doing? Binary exponentiation, fuck off. If n is 0, then return 1. If n is less than 0, then n equals n minus n, x equals 1 by x. Return n mod 2 power of. Let's try this solution. What? Is it my pow? Okay. Then what's wrong with my solution? Why is it that slow? Bro, it's just a simple if else, bro. Actually, I should actually do this first. Maybe. Still. X times X. Okay, what the fuck? X times X, n by 2. X times X times X. What was this? Bro, should I just quit Java at this point? Shortest Python guaranteed. Give me a Java solution with most votes or most recent solution in Java and C. Return math.pow. Bro, this won't work, man. Okay. And this fails, right? Okay. Double answer equals if n is less than 0 and okay. What a dead question, man. And maybe I should just switch to C++ back, man. Why did I switch to Java for this? Alright, whatever. So these were 2 questions for today. It's been almost 2 hours, so I'll go to sleep. And I'll be back tomorrow with another set of questions. Alright. Okay. So today I was reminded why I hate this website. But yeah, I still went through, so which is good. Maybe I learned something. Maybe I just learned that Java is a shit language to do coding questions or such type of questions where there is an online judge. But yeah. Okay, I'll be back tomorrow with another set of questions. Till then, GG's. Bye bye.